You're going to learn a lot about similarity theorem. You're going to learn a lot how to prove opposite side in a paragram of ABCD are equal. That's very important, and that question comes all the time in your exams. And you're going to learn how to use paragram properties to answer particular questions. And again, you're going to learn how to prove such theorems, in particular also how to prove that a shape is a paragram. So this is a very important question, and it's question 6 of grade 10 maths, paper 2. So 6.1 says, prove that the opposite sides in the paragram ABCD are equal. Okay, so now you're required to prove that the opposite sides are equal. So this side, let me put green, this side and this side is equal to this side and that side. Okay, so you are required to prove that. And of course, this is a paragram, meaning this is parallel to that, and this side is parallel to that. Okay, so this is a paragram. Prove that AB is equal to DC and AD is equal to BC. Let's do that. How do you do this? The way one would do this is just split these two into two triangles. Okay, so split these two into two triangles, meaning you're gonna end up having a triangle. This triangle, let's call it triangle ACD. Okay, and you have another triangle here, ACB. Okay, so you have two triangles, and of course we know that this is equal to that, right? So we know that AC is equal to AC. This is given, right? You've drawn it, or you can just say drawn or given. It's up to you. So you've drawn AC, the line AC. Okay, so AC is equal to AC. So what you're trying to do is, if you can prove that triangle ADC, or rather, I like just following up the letters, triangle ACD is similar to triangle ABC. If you can prove that, therefore, you can able to say, therefore, AB is equal to DC and AD is equal to BC. Okay, if these two triangles are similar, therefore the opposite sides are equal. Okay, that's what the similarity theorem say. This is a similarity theorem. Okay, in a nutshell. Take this down, remember it, it's very important. Okay, and then, so if you can prove that, so how to prove that? If you can see that, just closely look at this. If since AB and DC are parallel, right, you're given that. Therefore, this and this are equal. Do you agree? You see that? So let's call this 1, 2. Let's call this 1 and 2. So A1 and C1 are equal. Okay, and you see this is this. If this is 2, this is 1, this is 1, this is 2. So what we're saying is, we're saying A1, angle A1 and angle C1 are equal. Angle A1 and angle C1 are equal, and the reason is this is our alternate angles, right? These are alternate angles. If you look at it closely, okay, these are parallel and this are equal. Make sense? And then again, if you look at alternative angles, then you see this and that line here. This line is parallel to this line. Therefore, this is equal to that. You see? So we're saying angle A2 is equal to angle C2. Angle A2, don't want to make it bold. Angle A2 is equal to angle C2. And the reason is alternative angles. So what we are coming into conclusion is we see that A1, right, is equal to angle C2. And we see that angle A1 is equal to angle C1. Okay? Angle A2 is equal to angle C2, angle A1 is equal to angle C1. Now, these two triangles are similar, right? So this tells us that triangle ACD is similar to triangle, right? This tells us, or we can just say thus, just meaning from what we've proven above, triangle ACD is similar. I should have written triangle there. Triangle ABC. They are similar. Why? Your reason is you have, as you can see, you have a side and the angle and the angle, right? This side is got this side. This angle is got to that angle. This angle is got to that angle. So side, angle, angle, angle. Now, by that definition, this then implies that AB, so which is, that means this is equal to AB is equal to DC, okay, and AD is equal to BC. Make sense? So that means AB is equal to BC and AD is equal to BC. This is what we've been trying to prove here. We need to prove a similarity theorem. After proving that theorem, then we can safely say that we have proven that the opposite sides in a parallelogram of ABCD are equal. This is a very nice theorem. It's gonna come all the time, by the way. So you have to always remember this theorem, and this is how you always prove it. And this is 5 marks. So you get a mark for drawing AC, and you get a mark for indicating these alternative angles. It's 3 marks. And you get a mark for recognizing that now these two triangles are similar, and get a mark for writing these two. Let me know if you got a question and you like this content that we're trying to create here. Please make sure you like it. Please make sure you share with your friend. The reason why you're doing that is because we're going to get more people who are start looking at this content, and the bigger the audience, the better the content that I'm going to start creating for you. Okay, so let's go to 6.2. In the figure below, so we have this figure here. In this figure, you have A, E, C, F. So you have this parallelogram, and we are told that AD is parallel to BC. Okay, that's another information. Now they want us to prove that angle E1 and angle F2 are equal. Okay, so let's go. 6.2.1. So we want to prove that angle E1 is equal to angle F1. So where's E1? This is E1, okay, is equal to angle F2. This F2 here. Ooh, it's a lot going on, right? But the way to do this is actually like, look at the information that you have, try to figure out what you have and how you can actually figure out your answers, right? For example, we know this line and this line are parallel, and you have a line here. So by alternative angles, we know that F1 is equal to E2, right? Alternative angles. F1 is equal to E2. So we can write that down. So we're just saying F1, okay, is equal to E2. And your reason this is our alternate angles. So we're saying this, make it bold, this and this are equal. And let's write also that which line that are parallel. So line AF is parallel to line EC. Okay, we're looking at those lines. What else do you know? You see that these two here, they are equal to 180. E1 plus E2 are equal to 180. Angles in a straight line are supplementary. Also, these two here, F1 plus F2 are equal to 180. Angles in a straight line are supplementary. Okay, so what you can say, okay, cool. Angle E1 plus angle E2 is equal to 180 degrees. These are supplementary angles. And then you can say angle E1 is equal to 180 degrees minus E2. Make sense? By definition. And again, angle F1 plus angle F2 is equal to 180 degrees. Again, these are supplementary angles in a straight line. Therefore, angle F2 is equal to 180 minus angle F1. Now, F1 and E2 are equal. So meaning E1 and F2 are equal, right? So therefore, thus, angle E1 is equal to angle F2. Why? Because angle E2 is equal to angle F1. This is very interesting. Do you see it? Please let me know if you don't see it. I'm happy to do this question again because it's very important. It's going to come in your exams and you need to understand it. And it's a very nice question to grab. And this is 3 marks. So you'll get your answer by identifying this alternative angles. And of course, you get a mark for the supplementary angles. You don't have to get a mark for your answer here, right? But these are the 3 marks you get. Okay, let's go to 6.2.2. ABC, prove that ABCD is a parallelogram. Now, they want us to prove that ABCD is a parallelogram. Now, properties, before we just move, I want to give you, just to understand properties of a parallelogram. This is how you write parallelogram in short. Properties of a parallelogram. It's very important that you understand the properties of a parallelogram so that it's easy for you to prove if a shape is a parallelogram. Okay, so a parallelogram always gonna look like this, like a skew triangle or square or something. And let's call this A, D, C, B. Okay, so a parallelogram is, of course, opposite sides again are parallel. And another thing about a parallelogram is opposite sides are equal. Okay, opposite sides are equal and opposite angles are equal as well. So this is the information that you need to know. So if you can prove if you can actually prove that AD is parallel to BC and AD is equal to BC, then you've proven that ABCD is a parallelogram. If you can prove that, then you've proven that they are parallelogram. And lucky to us, we have already been told that AD and BC are parallel. Okay, but if you can prove that are equal, that's what you need to do. If you can prove just they are equal now, because already given that they are parallel, therefore this whole thing is a parallelogram. Make sense? So that's what you need to do here. So it's 5 marks. So it's a lot to do. but easy. Don't worry, right? We're gonna just zoom in into this picture, and look at it and try to dissect it and get the answers. Okay, so what you can do is, if you can prove that this triangle here, okay, is similar to this triangle here, okay, if these two triangles are similar, therefore all this side and this side will be equal. Therefore, if this side and that side are equal, therefore it's a parallelogram, right? So we need to prove so we need to prove that triangle, I don't want to make it bold, so we want to prove that triangle, oh gosh, triangle ADF is similar to triangle let's say triangle BCE. Okay, right. Let me just draw it for you. This is triangle ADF. Just have to be careful. ADF, and this is number 2, and this is parallel, and also that's a parallel, and this is 1. And BCE, so this is BCE. Okay, this is BCE. This is number 1. This is number 2. It's parallel. This is parallel. Okay. Now, the first thing to notice from here, right? You're trying to prove that triangle ADF is similar to triangle BCE. Okay. The first thing to see here is already that AF, okay, look at this, AF is equal to AEC. Why? Because we already told, right, that this is a parallelogram. So if it's a parallelogram, therefore this side and this side are parallel and this side are equal. So by that definition, AF and EC are equal. Okay, so we are saying AF is equal to EC. Why? It's given. We are told here. This is what we are told. We are told that AECF is a parallelogram. Given AECF is a parallelogram. That's given. Okay, so this, what we've discovered here is this is equal to that. Okay, and what else? We need to figure out other things. We are trying to prove that we are trying to prove that triangle ADF is similar to triangle BCE. Okay. Now, another thing that you need to recognize is E1 is equal to D1. E1 is equal to D1. This was proven, right? This was proven. Triangle E1 angle, we've proven this before, right? Angle, this angle here is equal to this angle here. This is what you've proven. Angle E1 is equal to F2. Sorry, F2, not F1. They're equal. This is proven, so you can just write that down. Angle E1 is equal to angle F2. This is proven. Or you can say given, because it is indeed given here. Okay. So what we have? We have this is equal to that. Now, another thing that we know, let me write this down. This, make it bold, Percy. This, for the people at the back, are equal. And this are equal. And one thing also we know is, you see that this is parallel to that, and you have a line over here and become alternate angles. D1 is equal to B2, alternate angles. Easy. You just have to be careful with it, right? Angle D1 is equal to angle B2, and your answer is alternate angles. Okay, so what we're saying is, we're saying B, okay, B2 is equal to D1, and your answer is alternate angles. And now we have a situation where these two triangles are similar, right? Why? Because you have a side and angle situation, right? You got a side and an angle situation. So therefore, by definition, thus triangle ADF is similar to triangle BCE. And your reason is side, angle, angle. Yes. Now we know that triangle ADF is similar to triangle BCE. If that's the case, therefore therefore this is equal to that. These two sides are equal. So therefore, or implies that AD is equal to BC by a definition of similarity, right? And if that implies, then this implies that A, B, C, D is a parallelogram. Why? Because AD is parallel to BC, that's given, and AD is equal to BC, and that's what we have proven. And that's how you get your 5 marks. Yes. That's how you get your 5 marks. Okay, so you got 5 marks. Please let me know if you don't understand this. It's very important. Just type in your question, something that you don't understand in your comments. I'm happy to go back and show you how we got here and redo this question because it's very important. It's going to come in your exam. Okay? So if you understand this question, you're definitely ready for your exams. So 5 marks. So of course, you're going to get a mark for identifying the right triangles to prove. So get a mark for this, and get a mark for that, get a mark for this, get a mark for that is 1, 2, 3, 4. And yeah, and get a mark for this. This is how you get your 5 marks. This is your question 6. It's a very nice question 6. And let me know if you got a question about this. And please make sure you subscribe, make sure you like, and make sure you share this with your friends. And I'll see you again on the next video. Boom.